Hello everyone. Previous lecture we have studied the concept related with the chapter straight line. In that we see the general form and some important examples related with the given general form. Now in today's lecture we go with new part, and in that we have to find distance. In the first case, we find the distance of origin from a given line. To define this concept, we consider one figure. Let us consider the coordinate axis. Here x and y axis. Let us consider one line. Okay, suppose this is our line. Here ax plus by plus c equal to 0. This is line ax plus by plus c equal to 0. We have to find the distance of the origin from the given line. And here remember, here shortest distance is the perpendicular which is drawn from here origin to this point N. Okay, remember this ON is the shortest distance and we have to find this distance. Okay, since our line is ax plus by plus c equal to 0 and here ON, suppose this distance is p, then we define or we find this distance by using the formula here p is the distance, and we find this by using inside the mod c upon square root of a square plus b square. P is the distance. We find this distance by using inside the mod c upon square root of a square plus b square. Here a, b and c are from our line. Let us see some important examples related with this part. Example, here in first given, find the distance of the origin. Find the distance of the origin from line here 7x plus 24y minus 50 is equal to 0. Okay, here one line is given. This line is 7x plus 24y minus 50 equal to 0. And we know this line is in the form here ax plus by plus c equal to 0. Okay, so we compare this equation with our general form. Comparing given equation with here ax plus by plus c equal to 0, then here we get value of a. Here a is 7, then we get b. Here b is 24, and in next c, here c is minus 50. Now we know a, b and c, then by using this formula we find the distance of the origin from the given line. Okay, so here I write directly distance p is equal to here inside the mod c upon square root of a square plus b square. Okay, this is equal to inside the mod, we know c is here minus 50, this divided by here inside the square root a square means 7 square plus b square means 24 square. Okay, now this is equal to here we get inside the mod minus 50 upon square root of, we know 7 square is 49 and 24 square is 476. Here is 476. Now this is equal to here inside the mod minus 50 upon here 49 plus 476 is 24 square is 576 and 49 plus 576 is 625. Here is 625. Now this is equal to here minus 50 upon inside the square root. We know square root of 625. Okay, here square root of 625 is 25. Then this is equal to inside the mod we get minus 2 only. Here modulus is given, so I write 2 only. So here distance is 2 units. Here distance is 2 units. Okay, and this is the distance of the origin from the given line. Remember this example. Let's go with our second example. Example here given, find the distance of of the origin from line here 3x plus 4y plus 15 is equal to 0. Again by using the same steps, here we find the distance. Okay, firstly we compare this equation with ax plus by plus c equal to 0. Comparing given equation with here ax plus by plus c is equal to 0. Okay, then we get value of a. Here a is 3. Then here we get b. Here b is 4. Then c is the last one and c is here 15. Now we know how to find the distance. To find the distance, here we use directly formula. Here distance p is equal to inside the mod here c upon square root of a square plus b square. Let's replace a, b and c in the given formula. So here we know c is 15. This divided by inside the square root. Firstly we have a square. A square means 3 square. Then plus b square means here 4 square. Then this is equal to, here this is equal to inside the mod here 15 upon square root of, we know 3 square is 9 plus here 4 square is 16 and this is equal to inside the mod here in numerator 15 as it is, this divided by inside the square root 9 plus 16. 9 plus 16 is 25. This is equal to inside the mod 15 upon, we know here square root of 25 is here 5. We know 15 upon 5 is 3 and this is equal to 3 units. 3 units. So this is the distance of the origin from the given line. So directly by using our formula, here p is equal to inside the mod c upon square root of a square plus b square, we find the distance. Okay, let's go with our second part in this chapter, and in that we find distance of a point from a line. Okay, so we go with new point. Here the distance of point having coordinates x1 y1 from a line, okay, again by using our one figure we define the formula. Let us consider the coordinate axis. Okay, this is our x-axis, here is our y-axis, origin is at O. Let us consider one line. Here, this is our line ax plus by plus c equal to 0. ax plus by plus c is equal to 0. Let us consider one point. Suppose this point is a P. This point is our P and having coordinates here x1, y1. We have to find the distance of this point from the given line. And to find the distance, we consider a perpendicular which is drawn from point P to the line, and suppose this distance is small p. Okay, here for point we consider capital P, and here for distance we consider small p. Okay, and to here find the distance, we directly have a formula, and to find distance formula is small p is equal to inside the mod here ax1 plus by1 plus c, this divided by square root of a square plus b square. Directly by using the same formula we find the distance. Let's go with some examples related with this part. Okay, so here in example given, find the distance of the point. Find the distance of the point a of -2, 3 from line here 12x minus 5y then minus 13 is equal to 0. Okay, again directly by using this formula we find the distance. Firstly, we compare our given equation with ax plus by plus c is equal to 0. Okay, so comparing given equation with ax plus by plus c is equal to 0. Here we get, here a is 12, b is minus 5 and c is here minus 13. Here also given one point. Suppose coordinates of given point are x1, y1. Okay, here I write given things. Given here a, and he is having coordinates x1, y1 and is equivalent to here -2, 3. Okay, let's go with our formula to find the distance. Okay, so consider distance is equal to p and is equal to inside the mod. In our formula is having x1 plus by1 plus c, this divided by square root of a square plus b square. Let's replace a, b and c. We also replace here x1 and y1. Okay, so this is equal to inside the mod we know a is 12 into x1, we know x1 is -2, then plus here b is given, we know b is -5 into here y1 is given, y1 is 3, and in last plus c, we know c is -13 and this divided by square root of a square plus b square. We know a is 12, so 12 square plus b is here -5, so -5 square. Okay, now this is equal to inside the mod. We know 12 into -2, here is -24, then -5 into 3, -5 into 3 is -15, and in last here plus -13 means here -13, this divided by inside the square root. We know 12 square is 144 plus -5 square is 25. Now this is equal to, here we know -24 minus 15 is -39, -39 minus 13 Minus 39 minus 13 is minus 52. This divided by, inside the square root, here 144 plus 25 is given. We know 144 plus 25 is 169. This is equal to, here minus 52 upon square root of 169 is 13. This is equal to, we know here 52 upon 13 is 4. So here minus 4 and is equal to plus 4 units. So this is the distance of given point from the given line. So very interesting example it is, very simple example it is. Let's go with our second example. Example given, find the distance of the point, find the distance of the point P of 2, 5 from line here 3x plus 4y plus 14 equal to 0. Okay, again directly by using our formula we find the distance. Okay, so here we compare our given equation with x plus by plus c equal to 0, then we get values of a, b and c. So here comparing given equations with x plus by plus c equal to 0, then we get here a is equal to 3, b is equal to 4 and c is equal to 14. Then here point is given. Suppose this point P is having coordinates here x1, y1 and is equivalent to here 2, 5. That is here x1 is 2, y1 is 5. Okay, here we know formula for distance. Distance P is equal to, inside the mod, here x1 plus by1 plus c upon square root of a square plus b square. This is equal to, inside the mod. Now we replace values of a, b and c, also x1, y1 in this formula. So here a is 3 into x1 is 2 plus b is 4 into y1 is 5 plus c. Here c is 14. This divided by, inside the square root, a square means 3 square plus b square means here 4 square. This is equal to, we know 3 into 2 is 6 plus 4 into 5 is 20, then plus 14, this divided by, inside the square root. We know 3 square is 9 plus 4 square is 16 is equal to, we know 6 plus 20 is 26, 26 plus 14, 26 plus 14, 26 plus 14, here is 40, this divided by square root of 25 is equal to, here 40 upon square root of 25 is 5 and is equal to 8 units. So this is the distance of given point from the given line. Again, very simple example it is. Directly by using the formula here inside the mod, x1 plus by1 plus c upon square root of a square plus b square, we find the distance. Now we go with our next part. In that we find the distance between the parallel lines. Third point, the distance between two parallel lines. The distance between two parallel lines. Distance between two parallel lines. Again, to define this concept, we consider one figure. Let us consider the coordinate axis. x-axis, here is y-axis, origin is at O. Now we have to consider the parallel lines. Suppose lines are like this. These two, first is L1, second is L2. Here L1 and L2 are parallel lines. Okay, here we have to find distance between L1 and L2. Here distance is like this. We consider again the perpendicular distance like this. Okay, suppose this distance is P and we have to find this P. Okay, and to find this distance, here we have a formula. Okay, firstly we define the line L1. Suppose this line L1 is having here AX plus BY plus C1 is equal to 0. Then second line is L2 and is having AX plus BY plus C2 is equal to 0. Here remember, in between two parallel lines, here coefficient of x and coefficients of x are same and here coefficients of y are also same. Here difference is only in C1 and C2. Okay, and to find the distance, here we have a formula. P is equal to inside the mod C1 minus C2 upon here square root of A square plus B square. Directly by using the same formula, we find the distance in between two parallel lines. Okay, so we go with one example to define this concept. Example, here in the example given, find the distance between parallel lines 4x minus 3y plus 5 is equal to 0 and here 4x minus 3y plus 7 is equal to 0. Okay, firstly remember, here given lines are parallel. Why? Since here coefficients of x are equal, also coefficients of y are also equal. Here difference is only in C1 and C2. Since coefficients of x and y are equal, we say these two lines are parallel to each other. Okay, let us consider here first equation is in the form ax plus by plus c1 equal to 0. Okay, so here we get c1 and here c1 is 5. Let us consider the second equation is in the form here ax plus by plus c2 equal to 0. Here c2 is equal to 7. So we know c1 and we know c2. So to find the distance in between parallel lines, here we have a formula. Firstly, I write distance is equal to P is equal to inside the mod C1 minus C2 upon square root of here A square plus B square. This is equal to, we know C1 is 5 minus C2 is 7. This divided by here inside the square root A square means, remember here A is 4 and B is minus 3. Okay, so 4 square plus minus 3 square. This is equal to here 5 minus 7 is 2. This divided by square root of, we know 4 square is 16. We know 3 square is 9. This is equal to here minus 2 upon square root of 16 plus 9 is square root of 25. We know square root of 25 is 5, so here we get minus 2 upon 5. And lastly, here we get 2 upon 5 units. So this is the distance in between two parallel lines. So directly to define or to find the distance, we use the same formula. Okay. So in today's lecture, we define 3 concepts. In first, we consider distance of origin from line. In second, we define the distance of a point from given line. And in last, we consider distance between two parallel lines. Okay, and we see some important examples related with this part. Thank you.